Hi, this is third lecture on binomial distribution. In last lecture, we have discussed about moment generating function of binomial distribution. So quickly revise how we can define moment generating function. Generating function of a binomial distribution. So we denote this by mxt, and mxt equal to expectation of e to the power tx. X is a random variable, and that is equal to summation x equal to 0 minus infinity to infinity e to the power tx into f of x. So, and this after calculating, we get this is equal to p e to the power t plus q to the power n. So this is the moment generating function of a binomial distribution. So with the help of moment generating function, we can find the mean and variance of binomial distribution. So let the example be find the mean and variance of the binomial distribution from its moment generating function. So we have to find the mean of binomial distribution, variance of binomial distribution with the help of moment generating function. So how we can find this? We know that moment generating function of a binomial distribution is mxt equal to p into e to the power t plus q to the power p into e to the power t plus q whole power n. So now with the help of this, we have to find the mean and variance of binomial distribution. So mean, first we find mean of a binomial distribution. We know that mean of binomial distribution is np, but how we can find with moment generating function? So mean is equal to, that is equal to expectation of x, and we denote this expectation of x, that is mu1 dash, and that is equal to, so how we can find? We differentiate, because we know that mu r dash is equal to we uh, rth derivative of mxt moment generating function at t equal to 0. So mu1 dash, that is equal to d by dt of, we differentiate moment generating function mxt at t equal to 0. So if we first derivate moment generating function at t equal to 0, then we get mean of binomial distribution. So let us differentiate this. So d by dt of What is mxt? It is p into e to power t plus q whole power n, and this at t equal to 0. So we have to differentiate with respect to t. So we can find the derivative of p e to power t plus q whole power n, that is n into p e to power t plus q to power n minus 1, and then again we differentiate this, so we get into p e to power t at t equal to 0. So now put t equal to 0, even let this be equation number 1. After differentiating we get this. So this, after putting n t equal to 0, so we get n into p e to power 0 plus q to power n minus 1 into p e to power 0. P equals 0 is 1, and we know that p plus q is equal to 1, so we get p plus q to power n minus 1 into p, and p plus q is equal to 1, so we can write this is equal to np, because p plus q that is equal to 1. So mean of binomial distribution, that is equal to mu1 dash, that is equal to expectation of x. So it is n into p. Now we have to find the variance. Now variance of x, that is equal to expectation of x square minus expectation of x whole square, that is also equal to mu2 dash minus mu1 dash whole square. So we have already find mu1 dash. Mu1 dash equal to n into p. So what we have to do? We have to find mu2 dash. So let us find mu2 dash. Mu2 dash, we double differentiate mxt with respect to t. We find the double derivative of moment generating function with respect to t at t equal to 0. So we can write this as d by dt of mxt at t equal to 0. But from equation 1, we have differentiate this, and after differentiate this, we get this. So we can directly use equation number 1, n into p. So we write this is equal to d by dt of n into n or np e to power t. So we can write np e to power t into p e to power t plus q to power n minus 1, and this at t equal to 0. So this is the first derivative. So we can use by using 1. By using 1. So now again we have to differentiate this. So we can take np to be common. We take np to be common, then e to power t, we have to derivate dy dt of e to power t into p e to power t plus q to power n minus 1 at t equal to 0. So np, what is the derivation? We can use first into second product of two function, derivative of product of two functions. So we can write e to power t into n minus 1 p e to power t plus q the whole power n minus 2, and then again p into e to power t. So we get p into e to power t plus q. So we get p into e to power t plus second, we have to derivate e to power t. So it remains same. So we get e to power t into p e to power t plus q to power n minus 1 at bracket close at t equal to 0. So NP, so if we put e equal to 0, then e to the power 0 become 1. So we get that I directly write n minus 1 into p. This is p into e to the power 0, 1. So we can write this as p plus q to the power n minus 2. And p into e to the power t, e to the power 0 is 1. So p, I have already written p this. So second, it is plus p plus q to the power n minus 1. So we know that p plus q equal to 1. So it is n into n minus 1 into p square, because p plus and plus np, or even you can write this as np into n minus 1 into p plus 1, because np plus q equal to 1. And this is n into n minus 1 into p square plus n into p. So this is mu2 dash, right? So we put the value of mu2 dash to find variance. So now variance of x, that is equal to mu2 dash minus mu1 dash whole square, that is n into n minus 1 into p square plus np minus mu1 dash is np whole square. This is np whole square. So that is equal to n n square p square minus np square plus np minus n square p square. So this is equal to n square p square cancel out. So we can take np to be common. We get 1 minus p, and 1 minus p equal to q. So this is npq. So variance of x is equal to variance of binomial distribution, that is equal to npq. So this is how we can find variance and mean and variance of a binomial distribution with the help of moment generating function. Now the next thing is recurrence relation. Recurrence relation for central moments. So we have to find the recurrence relation for central moment. So to prove that the binomial distribution, prove that for the binomial distribution, the relation mu r plus 1 is equal to pq into nr mu r minus 1 plus d by dp of mu r, where mu r minus 1, mu r plus 1 have their usual meanings. Usual meaning. They are moment about me. Right? or we call them central moment. This is r minus 1th moment about mean. This is rth moment about mean. This is r plus 1th moment about mean. By the mean of this relation, of this relation, find mu2, second moment about mean, third moment about mean mu3, mu4, and also find beta 1 and beta 2 and beta 2. Okay. So since mu r, the rth moment about mean of the binomial distribution, this is the rth moment about mean of the binomial distribution. Binomial distribution. So we have to find mu r plus 1, that is equal to pq times nr mu r minus 1 plus derivative of mu r with respect to p. So how we can define mu r? Mu r is equal to, this is the rth moment about mean. So expectation of x minus mu to power r, and this is summation x is equal to, it is defined for 0 to n, so we can write 0 to n x minus mu to power r into fx. Here, because fx is function is binomial distribution, it is defined only for 0 to n, or we can write this from 0 minus infinity to infinity. And because fx is defined from 0 to n only, so we can write in second x equal to 0 to n x minus mu to power r into, what is fx for binomial distribution? Ncx p to power x q to power n minus x. So this is where q is equal to 1 minus p. So q equal to, or we can write next step, we can write this is summation x equal to 0 to n x minus mu. Mu is the mean of binomial distribution is np. So x minus np to power r into ncx p to power x into q to power n minus x, where mu is equal to np and p is equal to, or q equal to 1 minus p. So let this be equation number 1. Let this be equation number 1. So this is our mu 1. So differentiate equation 1 with respect to p. We have dy dp of mu r, that is equal to summation x is equal to 0 to n. So we can differentiate dy dp of x minus np to power r into ncx into ncx p की power x into we can write q as 1 minus p की power n minus x. So even in first step we can write this as dy dp of x equal to 0 to n, because we know that dy dx of fx plus gx, that is equal to fx dy dx of fx plus dy dx of gx. So we can write this as this is equal to summation x is equal to 0 to n d by dp of ncx x minus np की power r p की power x 1 minus p की power n minus x. So we can differentiate this by taking first function, second function, and third function. So it is the product of three functions. So we can differentiate this summation x is equal to 0 to n, ncx to be common, and then we put bracket. So first function x minus np की power r, p की power x, derivation of first and second function, derivation of third function. So what is third function? It is n minus x into 1 minus p की power n minus x minus 1, and again 1 minus p, derivative of 1 minus p, that is minus 1. Now we differentiate second function. So we can write x minus np की power r into 1 minus p की power n minus x, first and third function as it is, and derivation of second function, it is x into p की power x minus 1, plus now we differentiate first function, it is r x minus np की power r minus 1, and again we differentiate x minus np, so we get with respect to p we get minus n into 1 minus into p की power x into 1 minus p की power n minus x, and then bracket close. So now we can write this as summation x equal to 0 to n. We can take already take ncx to be common, so we can rearrange this. So we can write this as x minus np की power r into 1 minus into 1 minus, even we can take uh, minus to be common, minus, so we can write this as minus n minus x p की power x 1 minus p की power n minus x minus 1. So this is the first term, and the second term is plus x into x minus np की power r 1 minus p की power n minus x into p की power x minus 1, and plus third is minus nr x minus np की power r minus 1 p की power x 1 minus p की power n minus x. So let this be equation number 2. So this is our d mu r over d. Multiplying both side, multiplying both side of 1 by pq we get, because we have to find mu r plus 1 equal to pq n r mu r minus 1 plus dy dp of mu r. So we have to find pq into d mu r upon dp. So we multiply both side by pq of equation 1. So pq d mu r over dp, that is equal to summation x equal to 0 to n ncx minus x minus np to power r n minus x. When we multiply it by pq, so p into p की power x become p की power x plus 1, because q is equal to 1 minus p. So we can write 1 minus p की power n minus x minus 1 plus 1, so it become n minus x. Is it clear? Because we put q equal to 1 minus p. So now if we multiply it, then powers are added. So 1 minus 1 becomes 0. So we get 1 minus p की power n minus x plus second x into x minus np to power r. Here 1 minus p, so it become 1 minus p की power, it is n minus x, so n minus x plus 1 into p की power x minus 1, so it become p की power x into p की power x. So this is the second term, and third term is minus nr x minus np की power r minus 1 p की power x plus 1 and 1 minus p की power n minus x plus 1. So we take in first and second term, we take x minus np की power r, p की power x, and 1 minus p की power n minus x to be common. So we have minus p into, so in first term we have minus p into n minus x, plus in second we have x into 1 minus p. Yes. Minus in third term we can write nr. We can split p की power x plus 1 as p की power x into p. So we can write p here 1 minus p की power n minus x plus 1 as 1 minus p की power n minus x into 1 minus p. So we can write 1 minus p here into x minus np की power r minus 1 into p की power x into 1 minus p की power n minus x. So we can write this. So in next step, this is summation x equal to 0 to n ncx x minus np into p की power x minus np की power r into p की power x into 1 minus p की power. So 1 minus p we can write q. So we can write this as q की power n minus x. And when we solve it, the term in the bracket, we get minus np plus px plus x minus xp. So px and px cancel, so we get x minus np. We get x minus np. So x minus np into x minus np की power r, it become x minus np की power r plus 1. So we directly write here this. So we can write x minus np की power r plus 1. This is r plus 1. And minus, we can write n r p, 1 minus p is q. So it is x minus np की power r minus 1, p की power x, and again q की power n minus x. So we can split this now. We can write summation x is equal to 0 to n x minus np की power r plus 1, and then we can write in bracket ncx p की power x, q की power n minus x, minus nrpq summation x equal to 0 to n x minus np की power r minus 1 into ncx p की power x, q की power n minus x. And this is this whole term in the bracket. This is r plus 1, mu r plus 1, r plus 1th moment about mean, minus nrpq. This is r minus 1th moment, r minus 1th moment about mean. So we can write this as mu r minus 1, because mu r equal to expectation of x minus mu की power r. So that is equal to summation ncf. We can write this as x minus mu is equal to np की power r into fx. So this is our fx. This is fx. This is also fx. And if we take mu r plus 1, it become expectation of x minus mu की power r plus 1. So this is first term, that is a r plus 1 moment, r plus 1 moment about mean. And r minus 1, if we replace r by r minus 1, then we get x minus mu की power, expectation of x minus mu की power r minus 1, and here we get r minus 1. So it is the second term. Right? So we can replace all these terms by r plus 1th moment and r minus 1th moment. So we get pq d mu r over dp is equal to this. So we have to find mu r plus 1. So mu r plus 1 is equal to nrpq mu r minus 1 plus pq d by dp of mu r. If we take pq to be common, then we get nr mu r minus 1 plus d by dp of mu r. So this is how we can find the recurrence relation. Mu r plus 1 is equal to, go through, pause the video, revise the content, and then proceed. This is very, very important. Okay. So which is the required result? Required result. Now, if we put r equal to 1, r equal to 1, 2, 3, we obtain mu 2, because mu 1 is always equal to 0. So when we put r equal to 1, we get mu 2, and mu 2 is equal to pq into nr mu 2 minus 1 is 1 plus d by dp of mu 0. And we know that mu 0 is always equal to 1 and mu 1 is always equal to 0. So if we put nr mu 1 is 0 plus mu 0 is 1, derivative of 1 is 0, So mu1 is equal to 0. So we get, but this is, oh, so this is r equal to 1. If we put r equal to 1, so this become, this is not mu0. If we put r equal to 1, this will become mu0 and this become mu1. So mu0 is equal to 1 and mu1 derivative of 0 is 0. So we get n and r is equal to 1. So r is equal to 1. So again here we can put, it also become 1 and into 1 into 1. So we get npq. And we know that mu2 is variance. So variance of binomial distribution is equal to npq. So with the help of recurrence relation, we can find the variance by just putting r equal to 1. So similarly, if we put r equal to 2, then we get mu3. Mu3 is equal to pq into and r equal to 2. So it becomes 2n mu1 plus dy dp of mu2. So mu1 is equal to 0. So pq first term becomes 0 plus dy dp of mu2. Mu2 is npq. This we have already found. And because q is equal to 1 minus p, so we can write dy dp of, even we can take n to be common. So p into, we can write q as 1 minus p. So it is a product of two functions. So we can put npq. First function is p, derivative of 1 minus p is minus 1, plus 1 minus p, derivative of p is 1. So we get npq minus p plus 1 minus p. And this is equal to npq. So we can write this as 1 minus p is q. So we can write this as minus p plus q, or that is equal to npq into q minus p. So this is mu3. Now similarly we can find mu4, and after calculating you put r equal to 3, you get mu4 equal to npq into 1 minus 6pq plus 3n square p square q square. So in this way you can find mu1, mu2, mu3 and mu4. Now we have to find beta 1. Now beta 1, we know that beta 1 equal to mu3 upon mu2 to power 3 by 2. So that is equal to mu3 is npq into q minus p divided by mu2. Mu2 is npq to power 3 by 2. So that is q minus p divided by n minus npq to power 1 by 2. And this goes to 0 as n goes to infinity. So beta 1 goes to 0. And beta 2 is equal to mu4 by mu2 square, and that is mu4 is npq into 1 minus 6pq plus 3n square p square q square divided by mu2 npq whole square. So we can take npq to be common. So if we take npq common, then it becomes 1 minus 6 np, the 6pq plus 3 minus 3 plus 3 npq divide by npq whole square. So 1 npq cancel out. So again we can write this as 1 minus 6 pq divided by npq plus 3 npq over npq. So that is equal to 1 minus 6 npq, 1 minus 6 pq over npq plus 3. So as n goes to infinity, so this goes to 3 as n goes to infinity. So this is how we can find beta 1 and beta 2. So next is standard binomial variate. Standard binomial variate. So first we define how we can define standard normal binomial variate. Let a random variable x, random variable x has binomial distribution, has binomial distribution with mean np and variance sigma square which is greater than 0. So sigma square variance is equal to npq. Then the new random variable that is z, capital Z, defined by z is equal to x minus np divided by under root of npq. We can define this z as x minus mean over standard deviation, and this has binomial distribution defined by this as binomial distribution with mean 0 and variance 1. That is expectation of z. If we find the mean of this z binomial variate, then it is 0, expectation of z equal to 0, and variance of z that is equal to 1. So a random variable having binomial distribution with mean 0 and variance 1 is called a standard binomial variate. Standard binomial variate. Or standard binomial variable. So let us discuss one article. If a random variable capital X has binomial distribution has binomial distribution with mean NP and variance NPQ, prove that the random variable z defined by z equal to x minus np, that is x minus mean upon under root npq, that is standard deviation, is distributed and has a binomial variate with mean 0 and variance 1. So by definition, expectation of z, that is equal to expectation of x minus np divided by under root of np, and we can take expectation 1 upon under root npq to be common, so it become expectation of x minus np, because expectation of c into x, that is equal to c into expectation of x. Here c constant is 1 upon under root npq. So 1 upon under root npq expectation of x, we can separate this expectation of x minus expectation of np, because expectation of x plus a is equal to expectation of x plus expectation of a, and a is constant, so we can write this. So in next step we can write expectation of np, that is np 1 upon under root npq, but expectation of x mean is np, it is given, minus expectation of np, this is constant, so np minus np is 0, so variance of z, expectation of z equal to 0. So mean of the binomial variate with random variable z, that is equal to, now we find variance of z, that is variance of x minus np over under root npq, and we know that variance of ax plus b is equal to a square into variance of x. So we can write this as 1 upon npq, because a is coefficient of x, that is 1 upon under root npq, so a square is npq variance of x, and variance of x is npq over npq, it is 1, so variance of z equal to 1. So in this way we can find mean of z, that is 0, and variance of z, that is equal to 1. Again go through, pause the video, revise, and then proceed. So quickly we will discuss 1-2 examples. Example 1. If on an average one ship in every 10 is sunk, find the chance . that out of 5 ships, expected 4 at least, or at least 4 will arrive safely. Arrive safely. So let P be the probability of success. Probability of success, and Q be the probability of failure. We know that P plus Q equal to 1. Probability of success means ship arrived safely, and probability of failure means it may be sunk. It is not arrived safely. So what is P? It is given that on an average, one ship in every 10 is sunk. So what is the probability of failure? Out of 10, 1 is sunk. So probability of failure is, then out of 10, 1 is not arrived safely. So 1 upon 10. What is P? 1 minus Q. And 1 minus Q is 1 minus 1 upon 10, that is 9 by 10. Because we know that there is a relation between P and Q. P plus Q equal to 1. So here Q is equal to 1 by 10, it is given. So we can find P equal to 1 minus Q. So according to the problem, here N equal to 5. Out of 5 ships, what we expect, 4 at least will arrive safely. Let X be the number of ships. Let X be the number of ships which arrive safely. So probability, we have to find probability of X is greater than equal to 4, because at least 4 will arrive safely. At least 4 means greater than equal to 4. That is either 4 will reach safely or all the 5. So because it is a binomial distribution, so we can write 5C4, N is 5, 5C4, P is 9 by 10, 9 by 10 to the power 4, Q is 1 upon 10, to the power 5 minus 4, it is 1, plus 5C5, P is 9 by 10 to the power 5, and Q is 1 upon 10 to the power 0. And after solving, we get 0.91854. So you can solve this and we get that. Second example, 6 dice are thrown 729 times. How many times do you expect at least 3 dice to show a 5 or 6? So again, we let P be the probability, P equal to probability of occurrence of 5 or 6 in one throw. So out of because we know that we have 6 total number of outcome in a dice in a single throw. We have 6. So out of these 6, we what are the probability of success? What are the events where we get success? 2, 5, and 6. 2 by 6, that is 1 upon 3. So this is probability of occurrence of 5 and 6. And what is Q? That we are not getting 5 or 6, we get 1, 2, 3, or 4. So that is equal to 1 minus P, and 1 minus 1 by 3, it is equal to 2 by 3. So we have number of trials n equal to 6 here. 6 dice are thrown. Right? So number of dice n equal to 6. So how many times do you expect? At least 3 dice. Out of these 6 dice, at least 3 dice to show 5 or 6. So probability of getting at least 3 dice, probability of getting at least 3 dice to show 5 or 6, that is equal to probability of x is greater than equal to 3. So we can write this as probability of x is equal to 3 plus probability of x equal to 4 plus probability of x equal to 5 plus probability of x equal to 6. And probability of x equal to 3, we can write this as 6c3 p की power 3, p is 1 by 3 की power 3, q is 2 by 3 की power 6 minus 3 is 3 plus 6c4 1 by 3 की power 4 into 2 by 3 की power 2 plus 6c5 1 by 3 की power 5 2 by 3 की power 6 minus 5 is 1 plus 6c6 1 by 3 की power 6 2 by 3 की power 0, and after solving we get 233 by 729, because this is the probability of at least 3 dice shows 5 or 6. But what we have to do, we have to find if we throw these 6 dice 729 times. So the expected number of such cases in 729 times is equal to 729 into probability of x is greater than equal to 3, that is 233 upon 729. So we get 233. So these are all about moment generating function, how we can find mean and variance from moment generating function. Then we find the recurrence relation. With the help of recurrence relation, we can find all the central moment, first, second, third, and fourth moment, coefficient of skewness. We can also find coefficient of kurtosis, and then we discuss some examples. So go through the video lecture. If you have any query, any doubt, you can put your doubts in the chat box. We will reply. Thank you. Have a nice day.